All right, welcome to the Tech Transfer Podcast. I'm here with Bennett talking about the compliant container today. So, Bennett, do you want to introduce us to the product? What is this technology?
Yeah, so I'll kind of give an overview and we can take it from there. So this is the compliant container developed by David Morgan here at BYU. And we've been assisting with some of the manufacturability of the core concept. So I believe the original disclosure was called rotationally compliant container mechanism or something along those lines, right? A little bit more technical.
Sure.
But basically the idea is using compliant mechanisms, origami-inspired research, right? He's developed these containers that can be used in any kind of industry, but we went, a little specific with maybe a cupcake or cookie type of container for the initial prototyping.
Okay, that looks great. And it's called a compliant container because it's one of these compliant mechanisms. It moves in a predictable way when you manipulate it, right?
Yeah, so it starts from one sheet of material, and then we introduce the folds and a very predetermined set pattern that we use. And then because of that, we can then rotate it into shape as a container versus just, folding something up from a flat sheet like they do with, kind of standard containers.
Okay, so we'll get more into the manufacturing and structure of the thing, but essentially the product should be a flat piece of paper and then it folds easily into a shape.
Exactly,
right?
yes. Yeah.
And how and why was it developed? What were the professors thinking?
So I'm trying to remember the exact kind of steps that Dr. Morgan was talking about, but I believe they were doing some related research that had to do with the pleats in the fold itself, right? And as they were doing that, they kind of stumbled across, hey, like this could actually make a kind of cool container, right? And so as they were working through it, they iterated through a bunch of different designs. So this was kind of the inspiration for maybe the cupcake style container.
Okay.
But then they also worked on, something that could be maybe like a takeout container, right? So you go to your Chinese restaurant and you've got something that you can take home, your leftovers.
And a bowl would sit right in that, I guess.
Bowl would sit right in that, right? And the idea was maybe you take it home, you can open it up, and you can eat your takeout right out of here, right? So you don't have to get any dishes dirty or anything like that.
And you can see just then it kind of pops back into shape.
Yeah. And so once you have the folds in, it's like a lot of compliant mechanisms, it can store some energy, right? And it's bistable in that it has one stable position here, and then you push it down. And this one's not quite, but it can have a second stable position as well. So a lot of the cool things just from compliant mechanisms generally also are existent in this research here.
And is there a size limit? Like what if someone wanted to do, I don't know, a potted plant? I'm not sure what you would put in a larger container, but could you do that?
Yeah, I imagine there's no real size limit other than just maybe practicability, right? Because since it starts as a single sheet of material, the larger your finished product, the larger that sheet of material is going to be. So you might run into limits once you start hitting, standard paper sizes for manufacturing or whatever your material is for these. Yeah.
And so for food products, paper makes a lot of sense. That's what people are used to, and it's easy to use. But could you do this with other materials? Are there any times when you would do that?
Yeah, I'm sure you could. You would definitely have to work on the specifics of the folds, right? Because obviously paper folds pretty well. You end up with a natural crease where it weakens the paper enough that it can move, but not so much that it, tears apart. So I imagine you could do something similar with maybe some plywood, right?
Okay.
Something like that. You could possibly do it with sheet metal if you got something that was really, really thin.
Oh, wow.
Again, the exact specifics would become important when you start working on that, but paper isn't the only material that this would be useful in.
Okay, I was thinking maybe like a fashion application, like kind of rigid cloth material.
Oh, yeah. Maybe like a canvas bag or something.
Yeah, something like that.
That could be really cool, yeah.
So, okay. And so what are the advantages to this over other products?
True advantages, I think, is in kind of the aesthetic value of the packaging, if I'm being honest, right? So functionally, it's going to operate like a container, like all of your other containers that you have, right? But from an aesthetic perspective, especially here in Utah, we have a lot of boutique type confectionaries, right? So we have like Crumble, we have Dirty Dough that just came out, we have all these types of places.
Lots of cupcake places.
Lots of cupcake places, right? So if you could have something in that space that could set you apart from the competition at basically the same price as your other packaging, right? Because it's no additional material, it's just in a different form. To me, that would give you a competitive advantage and be something that you would want to pursue. So, as an end user, I think that would be kind of the defining characteristic that would be different from the existing solutions that are on the market.
Okay, great. And that's so true. Like with Crumble Cookie, what does their packaging look like? Anyone who's eaten their nose is a pink box,
right?
And it looks good, and that's probably a major selling point for them. That the cookies are good too. But here you can see how you could sell more of something if it looks eye-catching. And it might also be less expensive, it seems like. Like most high-end packaging for food is, cardboard or some hard material.
Mm-hmm.
This looks just as good, but it's paper. Is that an advantage?
Yeah, I think it could be. It's definitely going to be similar in price, right? There's a good argument to be made that you could drop the price down, right? Mm-hmm. But at the very least, it's going to be comparable because it's going to be about the same amount of material. And then depending on which material you use, right, obviously you could drop the price a little bit.
Okay. And so as soon as I saw it as a cupcake package, that's all I can see it as right now. But what seemed like the most lucrative or easy to get to applications?
Yeah, so cupcake was definitely where we started. I kind of had the same thing, right? Where when I saw it, once I got cupcake in my head, that's kind of where I stuck for a while. Yeah. But I think any type of takeout application, right? So we mentioned Chinese food for some of the larger containers, right? So I think this is a good form factor for this. You could obviously put a wire handle in or something like that for taking it out. But that makes a lot of sense to me. And then actually, if you want to grab that one right there.
Sure.
There's one next to it, yeah.
Okay.
So this one, you can see by just changing the geometry, you can change the overall form of the packaging.
Yeah.
And so by reducing maybe the height of this a little bit, you could use it in cookies, right? Like I'm thinking somebody who wants to compete in the cookie space, they want to set themselves apart, that could be another application. So all of those are food. So what other applications?
Well, and that one looks like a holiday package to me. Like that would be a little thing of cookies or something you give someone, right?
Exactly. But other applications, you mentioned potentially a backpack, right? Some sort of container, maybe it has a drawstring that pulls it together, right? And everything closes really satisfyingly as well, right? You have that nice rotation as it closes. So
it kind of lie flat. Say you're packing for a trip, you sit all your stuff on the flat thing, and it folds into shape around it.
Exactly.
That would be
so
great.
You pull it up, pull your drawstring, right? It rotates into position. Anyway, so something in the fashion industry with, some sort of backpack or bag, right, that you have could be another application. I'm sure there are other applications, right? But I've been very focused on putting this together over the last couple of months, so I'm very much in this kind of lane of thinking right now. Yeah,
so let me brainstorm for just a second. So, it's a closed container, so it could be like loose candy, for example, like chocolates or something like that. Those coated candy chocolates.
Yeah, I think we have some of our cinnamon bears in one of these containers here.
Yeah, right here.
Yeah.
Okay. All right. Those are chocolate-covered cinnamon bears.
Yeah.
And then
very BYU.
Very classic BYU treat. So we should have some mint truffles somewhere here too. But let's see. Okay, well, I'll try to think of some other applications. There could be, I don't know, any kind of loose toy item. Would that be fun? I don't know, like marbles or something like
Definitely
that.
Could. Like if you've seen, especially as like overseas packaging for chocolates, right? It tends to be a little bit more elaborate than what we do here in the States.
Right.
Like I'm thinking like the Kinder Egg, right, type thing, where you could do something similar with this, where maybe it's some sort of confectionery treat, right, and then maybe you have a toy in there, right, and again, you have that nice kind of reveal. And packaging makes a huge difference. If you've ever bought like an iPhone or a really high-end electronic, the packaging and that unboxing experience, right, they literally hire people who just work on the packaging for these products. And so it's one way that you can stand out in a crowded market. So really anything that goes in a container, right, that you want to stand out and have kind of your branded image for what it looks like when it comes to your house in that unboxing process, I think this would be a good fit for.
Yeah, so really the business problem being solved is how do I make my product stand out? I'm selling something that's maybe a little bit of a commodity. There are lots of cookies out there, and this can make them look special and eye-catching.
Yeah, exactly.
So pretty great. And then with your background in prototyping, Bennett, you've done a lot of work on the manufacturing aspect of this. Like, where are we at on that? How does it get made?
Yeah, so we started out in a lot of different directions. We were hoping that we could just put some score lines in it and then it would pop into place, but we needed to actually have some way to reliably introduce the folds in the correct places. So kind of what that process would look like is we start with blanks, right? So we're cutting these out, and we're doing this by hand right now, but ideally you would just have a stamp, so you just run this through a mill, right? Automatically punch those out. Those then go into this form here, which puts some of the crease lines in it. A little hard to see probably on camera, but that's what we're working with. Then from there, we drop it into this form and press that in, and that gives us our first kind of more defined lines in here. And then from there, we ended up having kind of a final assembly aid, which drops down into the bottom. So you push this in over the top, and then you rotate the container down onto this, get everything nice and secure, pop everything back out, and that's where you end up with some of your finished containers. So this one's got a little peanut butter cup inside of it, right? But yeah, once you get to that last stage, then it comes in and it secures down, and then we printed these stickers. They go on over the top. Right. And everything's very manual right now, right?
Yeah.
But it got us to kind of the initial prototype stage of something that it's a little bit handmade at this point, but you could see how you could take all these steps, automate it. Instead of doing 3D printing, you could cast these in aluminum or machine them, put them on a hydraulic press. Depending on what kind of capital you wanted to invest, you could actually automate the transfer, from flat sheet into the next one, right? And just have an assembly line that cranks these off.
Okay.
It could be something very similar to the way that they make cupcake liners, right? Where they punch this through a hole, right? And these come out the other side. You could do something similar here as well.
Okay. Interesting. But these are actual forms that we have here at BYU. So if an entrepreneur were to license this, would we hand these off to them? Is that
absolutely.
step one?
Yeah, we'd give them all the CAD files, and honestly, I'd probably walk them through the process that we went through, from starting with a flat pattern and some of the designs that Dr. Morgan did by hand, and then walk them through the software that we used, the modeling techniques that we used, how we made these molds specifically, and then line out kind of the next steps of, you could do some investment casting to get these into aluminum, right? Some of the geometry changes that I would make to dial in a little bit more than they currently are, right? These are good. We're like 80% of the way there. But if we could get it a little bit closer, then obviously the manufacturing would go a little bit smoother. But yeah, we'd hand over all those files and some of the expertise that we've developed in making these to this point.
Yeah, and these are 3D printed, right?
Yeah.
So if someone not local, if someone in Hawaii licenses this, you would send them the files, they can print it off in their business, right?
Yeah. So we wouldn't have to send these to them. They could just print them themselves, print however many they wanted. And having the 3D file allows you to make some of those fine-tune adjustments on the fly.
Okay. And so how does this relate to existing manufacturing processes? Is this kind of typical? You mentioned the cupcake one. Is there another analogy? What other product would be like this?
Yeah, so sheet metal uses stamps and forms all the time, right? And even the current packaging processes, a lot of these you'll have score lines on paper. So when we first started, that's kind of what we started with. So you could imagine the blank, instead of just being completely flat, you could have something like this that already has the score lines in it. And maybe you'd have a tab here, right, so that it fits in the first mold oriented correctly. Right, or maybe a couple tabs so that it can move from one to the other with some automation assistance. But yeah, there's a lot of resources in these industry spaces and expertise when it comes to, packaging manufacturing that you'll be able to leverage. So you'll be able to take these and hand it off into these existing spaces, and then have experts in those spaces who are going to know way more than I do about the manufacturing of these products to help kind of move things along.
Yeah, so if I'm a new entrepreneur and I license this from BYU and I go to a manufacturer, they're not going to be confused by the concept.
No, yeah. And when we started, I took some of these to a manufacturer and showed it to them, and they were, they were like, yeah, we could definitely work through some of the issues of the manufacturing with this, not an issue.
Okay, fantastic. And then in terms of cost effectiveness, we're at stage one here, and like you say, it could be automated. If you were doing huge volume, I assume the price gets really cheap.
Yeah, absolutely.
But when you're just starting out, what's kind of the cost per unit, do you think?
Yeah, so if you're doing it by hand, like what I'm doing now, your cost per unit is going to be a couple bucks a piece, right? Because most of that being labor, right? The 3D printing was, maybe $1 for this, $2 for this, right? Really wasn't expensive on the tooling side, but then the labor of hand cutting things, right? That's where all your cost is coming in. Okay. So as you get rid of that with automation, obviously the capital investment of the automation of the molds, of maybe the hydraulic presses, that's going to be fairly substantial. But if you, amortize that over 3 or 4 years, right? Your cost per unit, I would imagine, would be pennies, honestly. It's a little hard to know without knowing the exact cost of the material that you're going to end up using. But, virtually, you should be running through these, thousands at a time.
Eventually, it's going to approach the cost of a round piece of paper.
Exactly,
right?
yeah.
So really inexpensive.
Yeah.
Okay. Well, great. Let's see. So we've talked about some applications. What about future implications? What if our professors tend to be ahead of the curve. I haven't seen any packaging this at all like this. Where do we go from here? What might be future products?
Yeah, so it's always hard to kind of look into the future and understand exactly what might be there, but it's not hard for me to see opportunities arising from manufacturing and distributing this packaging, right? So again, if it were me, I would start with the obvious low-hanging fruit, right? Confectionaries, any type of kind of boutique packaging. But then it wouldn't be hard to see how you could take some of these core concepts around the actual pleats and the folds themselves, and be able to expand into, I don't know, other industries. And I have a hard time like nailing something down. I'm still really much in the consumer space right here, but I don't know, anything that needs
maybe like shipping boxes, things
shipping
like that.
boxes, right? Like there's so many different areas where, you know, containers in general are used. And so if you have something that sets you apart, that has IP behind it, right, that you understand in a specific industry, it's not hard to see how you could translate that into other industries at the appropriate time.
Right. Okay. All right. Well, let's talk about kind of the business prospect here. So if someone sees this and they think, wow, that is a great product, I know there's going to be demand for it. What's their approach? Some entrepreneur who comes to you, what are the steps?
Yeah, so first step would be to reach out to me directly, right, through the Tech Transfer website, or we'll have my email in the YouTube comments here when we post this. Reach out to me. We'll talk about the technology, answer any questions that you have. If we can, we'll get you an interview with Dr. Morgan, right, so that he can talk through some of the technical aspects and explain a little bit more of the research that he's doing in the area. We'd negotiate a license for your use of it. Typically, that's going to be an exclusive license for all fields of use. We can narrow that if needed, but that would be our preference, right? We would negotiate the terms of that license, hand over everything that we have, so everything that you see here, plus the molds, plus the contacts that we have for the manufacturing, that would be given to you as part of the license, and then you would work to establish the manufacturing and supply chain for this. If it were me as the licensee, I would do a B2B type business. I think that would make a lot of sense with this. You wouldn't have to, right? You could make the cupcakes and then put them in your containers and, you know, be able to secure that IP. But if it were me, I think the better play, right, and this is just my opinion, would be to make the packaging and sell it to anybody who's interested, right? So brand it by customer for their specific use case, change the dimensions, you know, like we talked about, use it for cupcakes, cookies, takeout, right, and own that space so that anybody who wants packaging like this would have to come to me, if that makes sense.
Yeah, I really like the custom takeout application.
Yeah.
So if I were going to pursue that, I was an entrepreneur, I'd come to you, I'd license it, and then I haven't done manufacturing, I don't want to do that. So what I'm going to do is I'm going to get the files from you and so on, then I'll go to the manufacturer and say, I would like 1,000 of these or whatever number I have. And then my job really running the business, I think, is contacting Chinese restaurants and saying, these are cheaper than your boxes or they look better or whatever else, and just basically selling the product someone else is going to manufacture.
Exactly, right. So the technical expertise needed for this particular technology is going to be fairly low. We actually talked to Dr. Morgan about the potential of writing an SBIR and STTR grant to continue the research further. So as a licensee, right, you could do some of that legwork, help write that grant, work with Dr. Morgan, help continue the research if there's additional research needed in the manufacturing. But then it's very heavy on the marketing and sales side, right, which as a new entrepreneur, that might be something I'm more comfortable with than trying for something that's a little heavier on the technical side, right? That can be a little off-putting if you haven't done that before.
Right, and if anyone doesn't understand the SBIR opportunity, those are small business incentive, I don't know what the IR stands for.
Small business innovation research grants or small business technology transfer research grants.
Right, so SBIRs or STTRs, so there are certain grants that researchers can only get if there's a business involved. So if you license this and start creating a business, now you and Dr. Morgan qualify for new grants. And these are large grants. What are they? Typically $250,000 or something?
Yeah, about $300K last time that I checked. And that's for a phase 1. And so that would get you through the initial R&D. And then there's a phase 2 that's, I believe it's between $1 to $2 million, right? Which as a startup company, especially something that's not going to be super capital intensive, that could really get you across the finish line of getting your supply chain set up and getting that sales and marketing team in place to really push the sales side of it. Yeah.
So could someone come to you and license this contingent on them getting a grant like that? Then if the grant comes through, they know they're off and running. They're running a business at that point.
Exactly. I think that would be a smart move for them and for us, right? Because then it mitigates some of our risk of licensing it to somebody who may not have the capital behind them, as well as it gives them incentive and opportunity to, you know, approach researchers and say, hey, I've licensed the technology. If you're open to it, right, having somebody contracted to do some additional research who did some of the foundational research is obviously going to increase our chances of actually receiving the funding. And SBIR, STTR, those are just a few of the grants that we know fairly well that we would recommend. There's lots of other grant opportunities. Obviously, we'd want to connect you with the Utah Innovation Center and the Utah Innovation Fund, right? We have some contacts over there that we can make some introductions for. having capital behind your project can be really helpful. Obviously, we don't provide capital, but if we can make some introductions, always happy to do that.
Yeah, and I should add the Utah Innovation Center, they'll give you a grant. If it's the first time you're working with them, they'll give you a $3,000 grant just to go through the process.
Yes, and I forget about that all the time,
yes.
but like that's such low-hanging fruit to start out your
Yeah.
business, right? That grant just to write the grant, right? A grant to write
Right.
the grant, essentially. I think that's fantastic.
Yeah, it's regardless of whether you ultimately get the grant, but if you do, then you'd be adequately capitalized for your startup, so that'd
Yeah.
be pretty great.
Yeah, and one more thing about the SBIR is that it's non-dilutive funding. So it
Yeah.
comes from the federal government, but they don't take any equity in your company, right? There's no expectation that that's paid back, right? It is truly a grant, and you don't have to give up any kind of portion of your company to receive that, which is fantastic.
Yeah, and so we've had many startup companies that have come out of the university where they essentially bootstrapped by only fundraising through grants.
Mhm.
So personal money and grants, so there was no dilution of the equity holders
Yeah.
until they exited.
Right, which just makes your exit that much better.
Right.
Now, that doesn't mean that strategic partnerships aren't a good thing to do,
Sure.
right? If you find somebody who wants to invest in this and take, 30% of the company, that could be the best case scenario for you. But
Yeah.
this is another option, right?
And let's talk about timelines. So say I'm an entrepreneur and I license this from BYU and I do all these things. I'll apply for a grant, but let's say either I get it or I don't.
Mm-hmm.
If I'm ready to go to the manufacturers, like how much time is it going to take for me to get a manufacturer set up, create the product, and actually have something to sell to restaurants or whoever?
Yeah, so it's a little hard to say without knowing what kind of capital expenditure you're expecting going in, right?
Mhm.
Because molds and things like that, even if they're simple, it just costs a little bit of money, right? So
Yeah.
simple molds like this might be between 5 to 10K, depending on the manufacturer. But timeline for that, let's assume that you have the funding that's needed, right? We're not going to worry about
Mhm.
where that came
Right.
from. But you could probably have manufacturing set up with some initial test runs within probably 3 to 6 months, right? And that's a lot of back and forth with the manufacturer, a lot of tweaking of the molds, a lot of adjusting, pressures on your hydraulic press. Like there's just a lot that goes
Yeah.
into that, right? But that could probably get you your first couple of samples within 3 to 6 months. Probably within another 6 months, you should be fully set up at scale, ready to start producing, again, assuming that there's no huge,
Mhm.
wrenches thrown into the system that are going to cause you to need to pivot too much, right? That's just assuming that you can walk through the process. But
Sure.
within a year, it wouldn't be hard to imagine that you have this set up, manufacturing, you have your costs down, you're able to operate at scale, and then really you're just focusing on the sales and marketing and promotion of your B2B business, which I really like
Yeah.
B2B with these types of technologies because you're selling hundreds, thousands, tens of thousands of units at a time.
Mhm.
It's not 2 here, 3 here, 4 there, right? It's like you're going to
Yeah.
set up somebody for 3 months of their manufacturing of cookies, right? You're going to set them up with all those boxes that they need to have on hand. So
Yeah.
your average sales order price goes up. Your margins are still relatively good,
Mhm.
right? But you can get away with a smaller sales team who's connected in the industry rather than a large sales team who's trying to direct to consumer market the product.
Okay. Yeah, that makes sense to me. So if an entrepreneur takes this forward, when an entrepreneur takes this forward,
Yeah.
we're really looking at a 1-year experiment. Within a year, you're going to know if you have traction, you're selling these things.
So the timeline would definitely be affected by a grant proposal. So if you were writing the grant, I would anticipate that to take anywhere between maybe 3 to 6 months, right? There's just a lot of effort that goes into it. And then typically I would say maybe 6 to 12 months to hear back on whether or not the grant was approved, right?
Mhm.
And then that would fund you for about another 6 to 12 months, right? So if you do go the grant route, that may push out the timelines a little bit, but having that 300K-ish, right, to put in at the kind of start of your business can really help springboard you further into success, right? Because if you just bootstrap it, you can definitely be successful, right? But having
Sure.
done that myself on other products, everything's just a little bit more challenging, and it's a lot of legwork just running around because you don't have the capital to put behind it. So.
Yeah. Great. So a technology like this, it's a cool technology. It seems destined to get out there. It'll be packaged in cupcakes or whatever. What do you see as kind of, at BYU, we try to commercialize technologies to serve the world. What do you see as the benefits of a technology like this?
Yeah, I think the first thing that comes to mind is just the innovation behind it. Anytime you're trying to do something new, it can be hard, right? Like it can be hard to truly think of something new. So just the innovation coming out of something like this would be really fun to be involved in. And then the other thing is that the technology is really accessible, right? Like it's a really good project for kind of a startup entrepreneur, right? Maybe you've never done it before. Maybe you've never been through the process of starting a company and spinning it out and then exiting from that company. I think this is a really good piece of technology. Obviously a serial entrepreneur could pick it up, right? They've done it many times. They would definitely understand this. But if this is your first time, this is something you could definitely get in, understand quickly, and have some really early success.
Yeah, and then I also think like every startup company creates jobs, and usually meaningful jobs when they're university technology. Almost all job creation in the US comes from startup companies, not from large corporations, so that's super important. And then I think it's worth pointing out that the startup companies that are launched with our BYU technologies, that our technology just kind of gets them into the marketplace, and then they'll move beyond that. Like a company like this could come back later and license an origami box from us, or maybe make their own products and just move in some directions, but you need something to get you started, and this seems like a great option.
Yeah, no, I think so.
Well, great. Well, good. Well, thanks, Bennett. This is a great, exciting opportunity. What do you hope to see? Where would you like it to go from here?
Yeah, so what I'd love to see from this is just anybody who's interested in the licensing, please reach out. We love to have those conversations. Something like this, I imagine, will get picked up pretty quickly, right? But if this is gone by the time you reach out, we have a huge portfolio of technology, right, of other things, other projects that we're working on. We're prototyping other things, right, so we can show you those kind of behind the scenes. So what I'd love to see is, honestly, somebody come in, pick this up, get a company running, make it be successful. And those who miss out on maybe this specific opportunity, reach out, get connected with the tech transfer office, learn more about the opportunities, and we can help kind of walk you through that process of licensing technology, spinning off a company, applying for grants, introductions to professors, all those types of good things.
Absolutely. Well, that sounds great. Well, thanks for telling us about the compliant containers. It's an exciting technology and one more great thing coming out of BYU.
Yeah, thank you.